Good day everyone. We are here to present Lesson 5, Probability Density Function of Continuous Random Variables. Motivation. Probability density function as analog of probability mass function. In the previous lesson, for discrete random variable x that takes on a finite or countably infinite number of possible values, there is probability distribution or probability mass function. P, x equals x is for all the possible values of x. So now, for the continuous random variables, the probability that x takes on any particular values x is 0. That is, finding p x equals x for a continuous random variable x is always known to be 0. So instead, we will need to find probability x falls in some intervals a, b, that is, we'll need to find p a less than times less than b. So we can use a curve called probability density function or fx for this purpose. Even though a fast food chain will claim that hamburger weighs 100 grams, a randomly selected hamburger might weigh 98 grams while another might weigh 103 grams. What is the probability that a randomly selected hamburger weighs between 95 and 105 grams? This is if we let x denote the weight in grams of any randomly selected hamburger. What is p? 95 less than times less than 105. Assume that we selected 100 hamburgers and created a histogram of resulting weights. Perhaps this histogram might look something like this. So we will show you the histogram. So this is it. Okay. Next, if we decrease the length of the class interval on the histogram, then the histogram will look something like this. So, kapag naman dinecrease daw natin ang length of the class intervals, ang histogram naman ay magiging ganito ang itsura. So, yun. If nakita nyo na, next naman, if we push this further and decrease the intervals even more and selected even more hamburgers, say 1,000 or 10,000, the intervals would eventually get so small that we could represent the probability distribution of x not as a histogram but as a curve by connecting the dots at the top of the tiny rectangles that in this case might look like this. So we will show you the probability density function or the curve. Okay, kapag nakita nyo na, that such a curve is denoted as fx and is called a continuous probability density function. The area of each rectangle equals the relative frequency or percentage of the corresponding class, and the area of the entire histogram equals 1. Finding the probability that a continuous random variable x falls in some interval of values involves finding the area under the curve fx sandwiched by endpoint of the interval. In the case of this example, the probability that a randomly selected hamburger weighs between 95 grams and 100 grams is then this area.
So, discussion. Probability density functions. The idea behind probability density functions of a continuous random variables. We can now formally define it to the class. Definition. Let x be a random variable. The probability density function fx is a function that satisfy the following properties. A. The height of the graph fx must be greater than or equal to 0. For all real number x, that is the graph of the equation must lie on or above the horizontal axis for all possible values of the random variables. The total area under the curve fx is 1. analogous to the probability mass functions or probability distribution of a discrete random variables. The first property is about properties being non-negative, and the second property is about properties adding up to 1. You can use probability density functions to find that x lies in some interval from a to b by considering the area under the graph of the probability density functions over the interval a to b, that is a less than negative times less than negative b equal fx dx equal area under the curve fs sandwiched by a and b. This is also familiar to the idea that probability that lies in some discrete set A may be obtained by summing the probability for the distinct values in the set A, that is px equal a equal summation of p x equal I. Simply by change sounds that appeared in the discrete case to integrals in the continuous case. We should not assume that the learners know their calculus, but we can tell them this is what they have to endure calculus, as it has many uses, especially for probability and statistics. Example 1. Uniform distribution, also called rectangular distribution. Suppose that your friend is always late, and that the continuous random variable x represents the time from when you are supposed to meet your friend until he shows up. Suppose that your friend couldn't arrive a minute late or up to 3 minutes late with all intervals of equal time between equality likely. For example, if A equal 10 and B equal 60, and your friend is just as likely to be from 10 to 20 minutes late as he is to be 25 to 35 minutes late. The random variable x can be any value in the interval from 10 to 60. That is because any two intervals of equality length between 10 and 60 inclusive are equality likely. The random variable x is said to follow a uniform probability distribution with the probability density functions of x if x equals c, if a less than times less than b, or some constant c, and suppose f is 0 outside the interval a to b. First is what is value of c, and the second one is suppose that a equals 0 and b equal 1. What would be b 0.1 less than x less than x less than b plus 0.2. Assume b, a and b plus 0.2 less than b. Answer. Draw the probability density functions. So, yan. Okay. Since the total area under the curve, which is the area of the rectangle formed in the graph, should add up to 1, then c, b, negative a equal 1, thus c equal 1 slash b negative a. we call a uniform distribution. Probabilities would be uniformly dependent on the length of the interval. Example, triangular distribution. Let x a continuous random variable whose probability density functions is fx negative 1 negative x if negative 1 less than times less than 1. Verify it is probability density functions and calculate p 0 less than x less than 1 and a half. Answer. Draw the probability density functions and observe the triangular distribution. So this is the triangular distribution. Since the total area under the curve, which is the sum of two right triangular triangles, each with the area of 1/2, as learners y, add up to 1. Now to calculate p 0 less than times less than 1 and a half, as we add 0, the three are two right triangle to the left and right of 0. Tell learners this means that p 0 less than x less than 1 equal p negative 1 less than x less than 0 equal 1 and a half. There we can form a smaller right triangle formed from 1 and a half to 1, whose area is 1 and a half times 1 and a half times 1 and a half equal 1p. So that we should know that p 1 and a half less than x less than 1 is 1p. And thus we can compute. Remind the learners about the symmetry at 0. That the three are two right triangles to the left and right of 0. Tell learners that this means that p 0 less than times less than and a half of p. An alternative way to compute p 0 less than x less than 1 and a half is to remind the area of the trapezoid. The sum of the base multiplied to half of the height. A trapezoid can be as shown below with base 1 and 1 and a half and a height of 1 and a half.
So, dumako naman tayo sa enrichment. Pseudo-random numbers between 0 and 1. Suppose we consider real numbers randomly chosen between 0 and 1, for which we record x as the random number translated to one decimal place. For example, the number 0.034212840007 is recorded as 0.0 as the first decimal place is 0. Note that this means we are truncating and not rounding. If the mechanism generating this number has no preference for any position in the interval 0, 1, then the probability of x is a discrete uniform distribution. PR x equals 0.0 equals PR x equals 0.1 equals PR x equals 0.9 equals 1 over 10. Now, suppose that instead we recorded it to two decimal places, then PR x equals 0.00 equals PR x equals 0.01 equals PR x equals 0.99 or equals 1 over 100. If we record the first k decimal place, the random variable x has 10k possible outcomes, which with probability 1 over 10k. The spreadsheet application Microsoft Excel has a function that produces real numbers between 0 and 1, selected so there is no preference for any position in the interval 0 1. The actual mechanism is based on a deterministic generator of numbers called linear congruential generation. So that in a principle, at some point, there will be a cycle to repeat the number generated, although it will take a while to do so. This is why this is more aptly called random number generator. If you enter equal R, A, and B, close and open parentheses in a cell, and hit return or enter, you will obtain such a pseudo-random number. As we make the distribution finer and finer with more and more values chosen, the probability that any of these discrete random variables lie in the interval 0.1, 0.3 is always 0.2. Thus, x gets to be closer and closer toward continuous random variable with a uniform probability density function fx equals 1 when 0 less than times less than 1. Key points. For continuous random variable x, the probability p x equals a for some value is always 0, 1 for p. Next is for continuous random variable, we must consider the probability that it lies in an interval. To find this probability, we need to find the area under the probability density function on the given interval. Total area under a probability density function equals 1. A probability density function cannot be negative since if they were a negative probability could be obtained, which is not allowed. The probability density function is analogous to, but different from, the probability distribution for a discrete random variable. For the discrete case, the probability distribution sums up to 1, while for the continuous case, the total area under the curve is 1. So, ayun, thank you sa panonood at sana ay naintindihan nyo. Thank you!
Blackpink is the revolution.